Let's talk about one of the most important ideas in all of programming, abstraction. Now, I know it sounds kind of complicated, maybe a little academic, but I promise you, it's something you already get, something you use every single day. If you've ever felt a little fuzzy on what it really means, well, you're in exactly the right place. Let's jump in.
So let me ask you a question. When you get in your car to go to the store, do you need to know how the internal combustion engine works? Do you have to have a deep understanding of the transmission system or the firing order of the cylinders?
Of course not, right? All you need is a really simple interface. You've got the steering wheel to turn, pedals to go and stop, and a button or a key to get the whole thing started. You're dealing with the idea of the car, not all the greasy, complicated machinery that's humming away under the hood.
And that, right there, that is the core idea of abstraction. It's the simple, powerful act of separating what something does from how it actually does it. You're basically an expert at this already, and you didn't even know it.
Okay, so let's put a formal name on this. Now that we've got the basic idea down, we can see that abstraction is really just the process of hiding all the messy details to make something way easier to interact with.
And here's a really important point. Abstraction isn't about getting rid of the complexity. All that complicated stuff is still there. It's about managing it. It creates this nice, clean boundary, kind of like a wall, between all the inner workings and the user who just wants to make something happen.
I mean, think about a microwave. You pop something in, you hit the 30 seconds button, and you press start. You don't need to know a thing about magnetrons or radio waves or any of that complex physics. The machine gives you a super simple set of controls and hides all the science. That is perfect abstraction. Okay, so we've pretty much nailed the real-world stuff. Now let's bring this idea into the world of software development. Because in programming, this isn't just a nice-to-have idea. Oh no, it is absolutely crucial if you want to build anything remotely complex. So in the programming world, abstraction usually shows up in two main flavors. First, you've got data abstraction. This is all about hiding the nitty-gritty details of an object's data. And then there's process abstraction, which is about hiding all the complicated steps inside a function. Our car example? That's a classic case of process abstraction. We use the turn-on process without having a clue how the engine actually rumbles to life. All right, talk is cheap, theory is one thing, but let's actually see what this looks like when the rubber meets the road. We're going to take our car analogy and translate it into some simple Java code so you can see it in action. What you're looking at here is a Java interface. The best way to think about this is like a blueprint, or maybe a contract. It's not the car itself, it's a set of strict rules for anything that wants to be called a car. Our contract is simple. It says any car has to have a way to turn on car, turn off car, and tell you what kind of car it is with get car type. See? It's all about what it can do with zero mention of how.
And here's where it all comes together. That interface is our blueprint. Then you've got the actual detailed implementations, the stuff under the hood, like a manual car class and an automatic car class. That's where all the hidden engine logic lives. And finally, you have the user, our main program, who is like the driver. The driver only needs to know about the blueprint. They can just call turn on car on any car object, and abstraction makes sure the right engine starts, whether it's a manual or an automatic. All that complexity is tucked away right where it belongs.
Okay, hold on. If you've been around programming concepts for a bit, there's probably another big word that's jumping around in your brain right now: encapsulation. It sounds really similar, right? And honestly, these two get mixed up all the time. So let's take a second and draw a really clear line in the sand.
Here's the simplest way to think about it. Abstraction is a high-level design idea. It's all about showing only what's necessary, focusing on what an object does. Encapsulation, on the other hand, is an implementation technique. It's about bundling the data and the code that operates on that data into one single protected unit. Let's go back to the car. Abstraction is the dashboard, the simple controls you use. Encapsulation is the sealed engine block that physically prevents you from just reaching in and messing with all the important parts. Both hide things, but for different reasons.
So we've defined it, we've seen it in code, we've even cleared up a super common point of confusion. But what's the big deal? Why is abstraction considered one of the absolute pillars of modern software? Look, at the end of the day, abstraction makes our lives as developers so much better. It's the core principle that allows us to build gigantic, incredibly complex systems without our brains just melting. It means we can swap out parts, like, say, upgrading the engine in our automatic car class to be an electric one. And as long as we stick to that original car blueprint, the rest of the program doesn't even notice. It doesn't break. This is how we get code that's more secure, way easier to maintain, and a whole lot less stressful to work with.
You see, abstraction isn't just a technical term for programmers. It's a really powerful way of thinking. It's about looking at any complex problem and figuring out what the simple interface is. By mastering this art of hiding what's not essential, you give yourself the freedom to focus on building something truly amazing.